Right now, at this very moment, as you are sitting wherever you are watching this video, something is happening at the edge of the observable universe that has left the brightest minds in astrophysics, in quantum mechanics, in theoretical physics, and in cosmology completely and utterly unable to provide an explanation that fits within the framework of everything that centuries of scientific inquiry, decades of space observation, and billions of dollars of research investment have built as our understanding of how the universe works, how it behaves, and what rules it operates by. And the reason this matters to you, sitting right here, right now, is not because it is an abstract academic puzzle happening at a distance so vast that it has no connection to your life, but because if what these signals from deep space are telling us is actually true, if the data being collected by the most advanced telescopes and the most sophisticated detection systems ever built by human civilization is being interpreted correctly by the scientists who are right now working through its implications with a combination of excitement and genuine fear that you almost never see in the controlled and careful world of professional scientific research, then everything, and I mean everything, not most things, not many things, but the entire foundational structure of physics that underlies every technology you use, every scientific understanding you have ever been taught, every model of the universe that human civilization has constructed from the moment we first looked up at the night sky and began asking questions about what we were seeing is either incomplete in ways we did not know, wrong in ways we did not suspect, or pointing toward a reality so strange, so counterintuitive, and so far beyond our current conceptual frameworks that the scientists confronting this data are struggling to find the language to describe what they are looking at without sounding like they have abandoned the rigorous, evidence-based approach to understanding reality that defines science as a discipline and separates it from speculation. The signals themselves, coming from galaxies so distant that the light carrying the information in these signals left its source billions of years ago, when the universe was younger, when the conditions of existence were different from what they are today in ways that cosmologists have spent decades working to understand and model, exhibit properties that should be impossible according to the standard model of physics, the theoretical framework that represents the accumulated consensus of over a century of experimental verification, mathematical refinement, and predictive success that has produced technologies ranging from transistors to MRI machines to the GPS systems that your phone uses to tell you where you are at any given moment. A framework so thoroughly tested, so repeatedly verified, and so practically successful in its predictions that the scientific community had reached a level of confidence in its fundamental correctness that made the possibility of signals like these, signals that behave in ways the standard model explicitly says cannot happen, feel like exactly the kind of thing that careful, rigorous, peer-reviewed science was supposed to have ruled out as a realistic possibility decades ago. The specific properties of these deep space signals that are generating such alarm, such excitement, and such genuine intellectual crisis among the physicists and astronomers who have been studying them are properties related to the fundamental constants of nature. The numbers, like the speed of light, the strength of gravity, the fine structure constant that governs the behavior of electromagnetic forces, and the other fixed values that are supposed to be exactly that, fixed, constant, the same everywhere in the universe at all times and under all conditions, the bedrock upon which all of physics is built, and without whose constancy the entire edifice of scientific understanding collapses into a chaos of unpredictability, where nothing can be calculated, nothing can be predicted, and the universe becomes a place operating by rules so variable and so context-dependent that the very concept of a law of physics, a rule that applies everywhere and always, becomes meaningless. These signals suggest that in the distant galaxies from which they originate, the fine structure constant on EE of the most precisely measured and most carefully verified of all the fundamental constants of physics, a dimensionless number approximately equal to 1137 that governs the strength of the electromagnetic interaction that holds atoms, together determines how electrons interact with photons, and underlies virtually every chemical and physical process that produces the world as we experience it, has a different value than it has here, in our galaxy, in our corner of the universe, a difference that should not exist if the laws of physics are truly universal and truly constant in the way that every successful physical theory ever developed has assumed they must be, a difference that is small enough that it took instrumentation of almost unimaginable precision to detect, but large enough and consistent enough across multiple independent observations and multiple independent research teams using multiple different observational methods and multiple different telescopes and detection systems, that the possibility of measurement error or instrumental artifact has been progressively and thoroughly eliminated as an explanation, leaving the scientific community facing the deeply uncomfortable conclusion that the data is telling them something real, something true, and something that cannot be accommodated within the current understanding of how the universe works without consequences for that understanding that range from profound to revolutionary to genuinely civilization-altering in their implications for how human beings understand their place in a cosmos that appears to be operating by rules more complex, more variable, and more strange than anything our current science has prepared us to encounter. The implications of a universe in which the fundamental constants of nature are not actually constant, in which the fine structure constant, or the strength of gravity, or the speed of light, or any of the other numbers whose fixity underlies all of physics takes different values in different parts of the cosmos, or at different moments in cosmic history, are implications that cascade through every branch of physics, every branch of chemistry, every branch of biology, and ultimately every branch of human knowledge and human technology in ways that are simultaneously thrilling in their suggestion of a universe far richer and far stranger than we imagined, and deeply unsettling in their implication that the foundations we thought were solid may be far more contingent and far more local than we ever suspected. If the fine structure constant is different in distant galaxies, then the chemistry of those galaxies is different. The atoms behave differently, the molecules empt differently, the stars burn differently, the planets form differently, and the possibility of life, consciousness, and civilization in those distant regions of the cosmos is subject to physical conditions so alien to what we know here that our entire framework for thinking about what life is, what it requires, and where in the universe it might exist needs to be fundamentally reconsidered from the ground up rather than simply extended from the local conditions we know to the broader universe we are trying to understand. The theoretical frameworks that physicists have been developing to try to make sense of these impossible signals range from modifications to the standard model that preserve its essential structure while introducing new physics to account for the variability that the signals suggest, to more radical proposals involving extra dimensions of space in which the apparent constants of our 4-hour mass dimensional experience are actually projections of higher dimensional quantities that vary across the landscape of a higher dimensional reality, to the genuinely mind-bending territory of multiverse theories in which our observable universe is just one bubble in a vast and perhaps infinite foam of universes, each with its own values of the fundamental constants, with our universe's particular set of constants being not a fundamental feature of reality but an accident of cosmic history, the specific values that happen to characterize the bubble we find ourselves in, with other bubbles having different values that produce different physics, different chemistry, different possibilities for structure and complexity, and ultimately for the emergence of minds capable of asking these questions. The observational history of how these impossible signals were discovered, verified, and gradually accepted as a genuine scientific crisis, rather than a measurement artifact or an instrumental error, is itself a story that illuminates how science actually works when it encounters data that challenges the most fundamental assumptions of the existing theoretical framework, because the initial reports of anomalous behavior in the fine structure constant from distant quasar. Observations were not immediately embraced by the scientific community as evidence of new physics. They were subjected to exactly the kind of intense skepticism, rigorous re-examination, and demand for independent verification that the scientific method requires before extraordinary claims can be accepted as evidence of extraordinary realities. The fact that this re-examination, this independent verification, and this demand for alternative explanations has progressively failed to find the error, the artifact, or the mundane explanation that would allow the anomaly to be dismissed without confronting its implications is precisely what makes the current scientific situation so genuinely significant and so genuinely alarming to the physicists who have spent their careers assuming that the standard model, whatever its known limitations and known incompleteness, was at least getting the fundamental constants right. The technological implications of a universe in which the laws of physics are not universal in the way we assumed deserve serious consideration, because every technology that human civilization has built, from the simplest circuit to the most powerful parties, Cayley accelerator, from the most basic chemical process to the most sophisticated biological intervention, rests on the assumption that the fundamental constants governing the behavior of matter and energy here on Earth are the same fundamental constants that govern the behavior of matter and energy everywhere in the universe, and a universe in which that assumption is false is a universe in which the question of whether our technologies would function the same way in different parts of the cosmos, or whether the physical and chemical processes that sustain life as we know it would operate the same way in regions where the fundamental constants have different values, becomes a question with profound and unsettling implications for how we think about the universality and the transferability of human knowledge and human capability across the cosmic distances that any truly spacefaring civilization would eventually need to cross. The philosophical dimensions of what these impossible deep space signals are telling us about the nature of reality about the relationship between the universe and the laws that govern it, and about the degree to which those laws reflect something fundamental and necessary about the structure of existence, or something contingent and local about the specific corn. Of the cosmos we happen to inhabit are dimensions that take us beyond the territory of physics and into questions that have occupied philosophers, theologians, and anyone who has ever looked up at the night sky and wondered about the nature of the reality they find themselves in. Because a universe in which the laws of physics vary from place to place is a universe that raises in the sharpest possible form the question of whether there are any truly universal truths about reality, or whether everything we know, everything we have discovered, and everything we have built our understanding of existence upon is local, contingent, and potentially inapplicable beyond the cosmic neighborhood we happen to call home. What the scientists studying these impossible signals are confronting right now is not just a technical puzzle requiring a technical solution. It is a fundamental challenge to the human project of understanding the universe we live in, a challenge that requires not just new mathematics and new observations, but new ways of thinking about what physics is, what its laws mean, and what it would mean for those laws to vary across the cosmos in ways that our current conceptual frameworks have no adequate language to describe or accommodate. The discovery process is ongoing. The theoretical responses are multiplying. The observational programs designed to gather more data and test the competing explanations are running on telescopes around the world and in space, and the scientific community is in the midst of exactly the kind of productive crisis that has historically preceded the greatest leaps forward in human understanding of the cosmos, the kind of crisis where the old framework has been shown to be inadequate, but the new framework has not yet fully emerged, where the data is pointing clearly towards something real and important. But what that something is remains genuinely uncertain in ways that are simultaneously deeply frustrating and enormously exciting. To the scientists working at the frontier of this extraordinary and potentially civilization-defining scientific moment, something impossible is happening in deep space. The signals carrying that impossibility have been traveling toward us for billions of years. They have arrived. They have been detected. They have been verified. And the scientists who have spent their careers building the framework that these signals are now challenging are sitting with the data, running the models, writing the papers, attending the conferences, and having the late-night conversations that precede every scientific revolution in history. And what comes out of this moment, what the new physics looks like, that can accommodate both everything we already know and the impossible signals that are now demanding to be explained, will be one of the most consequential intellectual achievements in the history of human civilization. An achievement that rewrites our understanding of reality at the most fundamental level and opens possibilities for knowledge, for technology, and for our understanding of our place in the cosmos that we cannot yet imagine from where we currently stand. Like this video, if this exploration of the impossible signals from deep space and what they mean for our understanding of physics, reality, and the universe gave you the sense of wonder, urgency, and intellectual excitement that a discovery of this magnitude genuinely deserves. Subscribe to this channel for the kind of serious, deeply researched, and genuinely engaging coverage of the scientific discoveries that are reshaping how we understand the cosmos, and tell me in the comments what you think these impossible signals from deep space mean for the future of physics and for our understanding of whether the laws of nature that govern our corner of the universe are truly universal, or whether we've been living inside a local exception to a far stranger and far more variable cosmic reality than we ever imagined possible.